Hi everyone, in today's video we are going to build a DIY home security alarm system. So to do that, we are going to use a PIR sensor. It's short for passive infrared sensor. You may not notice, but you must have already encountered PIR sensors in your daily life. For example, security alarms, automatic lighting, and thermostat systems. These applications don't require the sensor to detect an object's specific location, but just the fact that the object or people in a specific area are moving. Today we are going to learn about one of the most popular PIR sensors for hobby projects, HC-SR501. In particular, we're going to learn about how does this PIR sensor work and how to build a home security alarming system with this PIR sensor. First, let's take a look at this sensor. This sensor is mainly composed by two parts. First, the Fresnel lens, which is the plastic cover that you can take off. This part condenses light and provides a large range to the sensor. Second, the electronic board, which contains infrared sensor and processing chips. So, how does this sensor work? The passive infrared sensor has two parts that can sense heat. Normally, they both detect the same amount of heat from the surroundings. But when a warm person or animal moves by, it blocks one part of the sensor. It will create a difference between the detected heat. This difference triggers a signal that tells the sensor that something has moved. And when the warm thing leaves, the sensor changes again. Now we understand some basics about this sensor. Let's take a look at how to build a home security alarming system with this PIR sensor. First, you will need some hardware, an Arduino Uno or another type. I'm using Arduino Mega in this video, but the electronics schematic works also for Arduino Uno. You will also need a PIR sensor. HC-SR501 is the one that we are using. A buzzer, an LED, a 220 ohm resistor, and some electrical wires and a breadboard. Please find the links of the parts for purchasing in the description below. Now we are ready, let's build it. So let's first do a simple test. In this first test, you will need to connect the VCC pin of the sensor to 5 volts of Arduino, the ground pin of the sensor to ground pin of the Arduino, the output of the sensor to LED. Please note that the LED has a longer leg and a shorter leg. The output of the sensor needs to be connected to the longer leg, and the shorter leg of the LED will be connected to the ground of Arduino. For most uses, you can simply use this sensor as a standalone unit. When you start it up, wait for about 30 to 60 seconds for it to get ready. During this time, the little light on it may blink a little bit. After a minute, try to wave your hand in front of the sensor. You should see the light turn on. This is a great way to check if the sensor is working. At this stage, you can adjust the sensitivity of the sensor and the detection behavior of the sensor. To do that, you can manually adjust 3 properties of the sensor. So you have the first potentiometer, which is used to modify the time delay. The time delay is defined as the duration during which the output remains high after detecting a motion. By turning it clockwise, you will increase the range of detection. Please be gentle when you turn the yellow plastic screws to adjust the time delay. For the first sensor that I used, I turned it too hard that I broke it. So hope you don't make the same mistake. Similarly, the second potentiometer is used to modify the sensitivity or range of detection. By turning it clockwise, you will increase the range of detection. Finally, using this jumper, you can select the trigger method of the output signal. There are 2 possibilities. First, you can do single trigger. It means any motion detected during the delay time is ignored. For example, here, the second motion detected is ignored as it happened during the delay time. The other possibility is repeated trigger. It means every motion detected will trigger the high state of the output, no matter if it's during the delay time. So if you want to use single trigger method, select L, otherwise select H. Now let's try to build a home security alarm system with a buzzer, a LED, and this PIR sensor. So some of the connections remains unchanged. What you will need to change is you will need to connect the output of the sensor to the digital I/O pin 3 of the Arduino, and you will need to connect the longer leg of the LED to the digital I/O pin number 5 of the Arduino. In addition, we will need to connect this buzzer. So to connect this buzzer, you can see there is a plus sign on the surface of the buzzer. So the leg under the plus sign needs to be connected to digital I/O pin 9 of Arduino. And the other leg of the buzzer needs to be connected to the ground of the Arduino.
You can copy and paste this code in your Arduino IDE. The code is pretty simple. So we first define the pin numbers for the digital input-output pins. Then using the setup function, we can define them either as inputs or outputs. In the main loop, the PIR state is used to store the data read from the sensor. Then, depending on if this data is high, we either trigger the buzzer and the LED, or we just write low to these two pins. Then make sure that you chose the right Arduino board. Click on Verify to verify the syntax of the code and upload your code to your Arduino board after having it connected.
Now you're ready to test this home security alarming system. So congratulations! Now you're ready to build your own home security alarm system. If you found this video interesting, please don't forget to like and subscribe for more hands-on tutorials. If you have any questions, please leave a comment below. I'll be happy to help build your DIY project together. Thank you for watching. See you next time.